is the allotrope that had remained, and we call it amorphous carbon. Amorphous carbon is black in color, and it has the lowest density. Remember, when we are looking at the allotropes, we say that diamond has got the highest density, followed by graphite. Now we have amorphous carbon, which has got the lowest density. Then again, amorphous carbon is non-crystalline. What do we mean? It is not in a crystal form, like how we saw diamond and graphite. Remember, we said that for the allotropes of carbon, we have two major crystalline allotropes, and that were diamond and graphite. So there comes the third allotrope, which is amorphous carbon, and we say it is non-crystalline. So if the question comes asking for the non-crystalline allotrope of carbon, that would be amorphous carbon. And again, fairly conducts electricity. So at some point it can conduct electricity, but it's not all that a good conductor of electricity compared to graphite. Remember, diamond does not conduct electricity. Then under our amorphous carbon, we have the examples or other forms, but these forms fall under amorphous carbon. So we have those examples which fall under amorphous carbon. Number one, we have wood charcoal. Wood charcoal, this is the charcoal, the normal charcoal we use at home. We're gonna call it amanda. So this is the charcoal we use at home. We are calling it wood charcoal because it is got from wood. They get wood, then they burn it in limited supply of oxygen to make sure that we have the charcoal. Then we have animal charcoal as our second. Animal charcoal is got from animal bones. So they burn the bones also under a limited supply of oxygen to give us the animal charcoal. Then we have also sugar charcoal. Sugar charcoal is got from sugar. Remember, this sugar contains water. So what we do to get a sugar charcoal, we shall get sugar, then we add concentrated sulfuric acid. Remember, concentrated sulfuric acid is a dehydrating agent. It is going to remove the water content from the sugar, then we shall get sugar charcoal. Then followed by lamp black, and lastly coke. Remember, all these have got the same physical properties. In other words, most of these ones, if not all of them, are black in color. All of them are black in color. So we shall look at this in details. So we start with let's start with wood charcoal. In case you have any questions, you can use the chat. Jemima, this is not primary 6. Check on the timetable very well. This is senior 2. Thank you. So wood charcoal, we say it is formed when wood is heated in limited supply of oxygen. So this word limited is very important. This word limited is very important. For example, if we had too much, let's say if you had plenty of oxygen or excess oxygen, we shall not have the charcoal. Instead, the wood will burn into ash. It will burn into ash, just like how you have when you get charcoal and you put it on the charcoal stove, then you burn. Eventually, you get the ash. It is because there you're burning in excess oxygen. So during the making or during the manufacture of charcoal, we use limited supply of oxygen, or we use less oxygen. So I try to get this is a YouTube link. So what you need to do is to copy it, then you feed it in the YouTube, then you will see that process. It is demonstrated there, but we don't have all that much time to go through that video, but I request that after the lesson you can check it out. Just copy it and feed it in that part of the YouTube where they say search, then you'll be able to watch that video which shows how wood charcoal is made. Someone is saying that my voice is too low. Okay, sorry about that. It could be your device or mine or network, but I think I'm talking. In other words, I'm even making noise. Then secondly, wood charcoal is black. Is a black porous solid. So wood charcoal is porous. It has some those small holes, or the ones we call pores, in it. That's why when you add water, the water will be absorbed. Let's say if you have the charcoal, if you bought a sack of charcoal, then there is that ash that remains at the bottom of the sack. So if you add there water, the water will be absorbed, meaning that those small pores or those small holes in the charcoal take in that water, and it is a very good absorbent of gases. It absorbs gases. Normally this charcoal is used as medicine. Let's say if you have gas in the stomach, normally you go to the clinic or the pharmacy, they give you the charcoal, which is activated charcoal, those small tubs which are black in color. Or if the fridge, for example, if the fridge is having that bad smell, then you can add there, you can put there charcoal, a piece of charcoal, then it will be that gas, that bad smell will be absorbed. Yes, Jovia? Jovia, I see your hand up. You can unmute.
Teacher is also called amorphous carbon.
Yes, we are coming to that.
Okay.
Thank you. So I was saying that if you get a piece of charcoal and you put in the fridge, if it is smelling, then the smell will go. As long as if there is no liquid dirt, if it is just a gas, it will eventually go. So here we have some examples or some pictures. So if you have ever been in a village or where they make charcoal, normally they have this kind of thing. The one you're seeing here, whereby they get the wood, then they put it under, then they cover there with some soil to make sure that there is less oxygen entering, so that the wood doesn't burn into ash. I hope if you ever got a chance of seeing this, so that is what happens. So this is the charcoal, this is the wood charcoal, the one we use at home. I hope everyone knows this. This is the charcoal. So for the case of the fridge, you can get like one piece of this, then you press it in the fridge. Yes, Sherina. Yes, please.
Excuse me.
Yes, I'm hearing.
Have just joined. Is this the first? I have just joined.
Yes, it is. Thank you. Jovia? Jovia, your hand is still up?
No, teacher, I just forgot to raise down my hand.
Okay, thank you. You can lower it down. The topic is Grace. The topic is carbon and its compounds. It's a continuation of what we looked at last time, the first phase. Okay, so I'm saying that these are just some pictures showing the wood charcoal, the real wood charcoal. So you shouldn't think that is something new. This is what we do at home, or what we have at home. And this part can demonstrate exactly what happens when we are making charcoal. Just get wood, then cover it with some soil to make sure that there is less oxygen entering, to avoid the wood burning into ash. This is senior 2, not senior 3. Then we go to animal charcoal. Like I said, this is got from animal refuse. Like we can say animal remains, and burns in limited supply of oxygen. So you get the animal remains or refuse, and then you hit them also in a limited supply of oxygen. It is the same reason. Avoid the bones burning into ash. Then animal charcoal has a property of absorbing carrying matter, so it can be removed to remove color, and also is used to remove brown color from sugar during its manufacture. So we shall find that at times the sugar, there is that sugar that is brown in color. That means that that color was not removed very well, and at times you find that the prices are different. The one which is white and the one which is brown, the prices are always different. So if they ask you the use of animal charcoal, you can say it is used to absorb carrying matter, or it is used to remove brown color from sugar during its manufacture. We go on. So these are some of the examples or the pictures of animal charcoal. You can see all of them are black, and they won't look alike, but though they are different. So these are some of the animal charcoal. We go to sugar charcoal. Sugar charcoal, we say it is the very pure or the purest form of carbon. This is very important. Normally comes in paper one asking you which of the following is the purest form of carbon, and they put for you all the forms of amorphous carbon, including sugar charcoal. So this is the purest form of carbon, made by removing elements of water from sugar. So basically here we remove the water from sugar. Remember, this sugar is they are crystals, and for one of the properties of a crystal of crystals, it must be containing water of crystallization. So what is done here, the acid, we shall add there the acid which will remove the water of crystallization. So that's why we're saying that when sugar cane is dehydrated, when we talk of dehydrated or being dehydrated, it means that when that water is removed, so we call it dehydration. Just like if you went to the hospital and they say that your body is dehydrated, it means that it lacks water. So when that sugar is dehydrated or when the water is removed by concentrated, we need to use concentrated sulfuric acid. Not dilute, it must be concentrated, because it is only when it is concentrated that acts as a dehydrating agent. Then when you add it, then the sugar charcoal will be formed. So you can have this. You can also, this is the link. You can feed it in. Your YouTube. Then you can see how it is formed. Let me see if I can do it for you. I'm trying to see if I can, try to do it for you. Okay, we shall look at it as we wind up the lesson. Teacher, can you send us the link that is on sugar charcoal? Yes, I will send it. I will send it after the lesson to come in your notes. Then you will be able to watch it. Or maybe just a moment and stop sharing. So those who are interested in the link, I'll forward it. Don't worry. Then we continue. So those are the examples of sugar charcoal. Someone is asking for the link for senior 3. Please check on WhatsApp, or in that WhatsApp group you'll be able to see. So remember, this is a picture showing sugar charcoal. Sugar charcoal is spongy. Like it's like if you say how you see your the mattress that mattress, the way it feels, it is spongy, kind of soft. So you need to check it out. You need to check it out. So that is how it looks. It looks like this, the way you see it on the screen. We go to lamp black. Yes, please, Miss Ghana.
Teacher,
Yes.
I just want to ask, what is that for? What is
I beg your pardon.
what for what purpose do we use sugar charcoal? What's its advantage?
Of sugar charcoal.
Mm.
Okay, thank you. So sugar charcoal it can be used during the sugar manufacture. It can be used during the sugar manufacture. And also, since it is used, because when we remove the water content from sugar, then we get the real sugar, rather the real carbon, which is black, the real carbon. And we can also apply that carbon to do other things, like in the preparation of carbon dioxide. So after getting the sugar charcoal, then we can burn it, then we can be able to get carbon dioxide. Sugar charcoal is not sweet. So we go to lamp black. This one is formed during the burning of oils. For example, we have turpentine, we have petroleum, kerosene. Kerosene is the same as paraffin. And also it can be made after burning such oils in limited supply of oxygen. Yes, Ashley?
Yes, teacher, I wanted to know the YouTube link for if you wanted to access the video for sugar charcoal.
Okay,
I did
okay.
not see it.
Yeah, I'm going to post it. I'm going to post it. Don't worry. Okay.
Okay.
Kale, thank you. Then after manufacturing it, it can be used. It can be used to make ink for printing. To make ink for printing, and also the shoe polish. So you can know the key we use that is also made of lamp black. Then the ink for printing. So there are some pictures for lamp black. So we have this one. This is normally the shoe polish, like that. We go to coke. So once again, coke for it is the impure form of carbon. Remember we said sugar charcoal is the purest form of carbon. Then coke, it is the impure form of carbon, made by heating coal in absence of oxygen. So here we are saying in absence of oxygen. When we say absence of oxygen, it means that there is no oxygen at all. It means that there is no oxygen at all. So that's why we are saying in absence of oxygen, or what we can call destructive distillation of coal. So if you are defining this, if you are defining destructive distillation of coal, you would say that is the burning of coal in absence of air. And basically here we mean oxygen. When we talk of air, our main component here in air, it should be O2, which is oxygen. It is used as a reducing agent in extraction of metals like iron and zinc from their ores. When we talk of ores, we mean those minerals or those compounds that contain metallic elements. In this case, we can mean iron or we can mean zinc. So what do we do? For example, during the extraction of zinc, we can get zinc from zinc carbonate. There is an ore we use, which is zinc carbonate. We shall look at it when we go to senior 3, but I can give you a hint. So we call it zinc carbonate or spathic ore. Then when you heat it, you get zinc oxide and carbon dioxide, zinc oxide and carbon dioxide. So after getting zinc oxide, then you can easily reduce zinc oxide using coke. Coke is carbon. Then from here you will get the zinc element or zinc metal and carbon dioxide. So that is how we apply coke as a reducing agent. And then it is also used as a fuel, that is for cooking and so on. I'm seeing a hand. Yes, Shami. Shami, yes, please.
Excuse me, mister.
Yes, please.
Does impure mean that coke contains a variety of substances in it?
Yeah, it contains other impurities.
Examples of them.
Sulfur dioxide. Okay, thank you, Shami. So here I'm trying to demonstrate how we can use coke as a reducing agent. And we are saying in the extraction of zinc. So as I said, zinc can be got from zinc carbonate. You heat the zinc carbonate, you get zinc oxide and carbon dioxide. Then now you can use coke to reduce the zinc oxide. Then we end up with our zinc metal. Someone is asking for the meaning of the ores. I said an ore is a compound that contains other metallic elements or contains other elements. It is that compound that contains other elements. So we have many ores. So it is a compound that contains other elements. So this is also another link. This is also another link that can take us to see how we can make coke. So that's the picture of coke. See that all the forms of amorphous carbon, most of them are black. So this is coke. We go to chemical properties. Chemical properties. We say that all isotopes of carbon have similar chemical properties but different physical properties. So when we talk of the chemical properties, it is because all of them are made of carbon. All of them are made of carbon. So that's why we say they have the same chemical properties. Just like what I told you last time, that if you are in a family and you have the same father, all of you share the same DNA. However much you can look different. Some might be brown, others might be black, others are big, others are tall, others are small, like that. But all of you contain the same DNA, as long as you are of the same father. Can be different mothers, but the same father. So that's the same thing that is done here. These allotropes are the ones we named. Remember, we have we said graphite. We said graphite. Then we also had diamond. We also had diamond. And now we have amorphous carbon. Amorphous carbon. Don't worry about my handwriting. Amorphous carbon. So we have 3 allotropes of carbon. And remember, we said these 2 are crystalline in nature, but this one is non-crystalline, the one we have just looked at. Yes, Shami.
Miss, I beg on the definition of allotropes.
That is what we looked at before. So you need to check in the classroom so that you can be able to get it. Or maybe we can get a volunteer. Anybody who can help us define allotropes? Anybody still remembers how can we define an allotrope or allotropes? You can raise up your hand. Yes, I can't read your names like a link. Vivian. Vivian?
Allotropes are various forms in which elements exist without change in physical state.
I hope Shami has heard. You can repeat for the second time.
Allotropes are various forms in which elements exist without change in physical state.
Okay, thank you. This person here, maybe she can first tell us. You unmute and tell us your name because your name looks like a link here. Unmute, please.
Allotropy is the existence.
First wait. What is your name? Because what I'm reading it is like a link, something very long.
My name is Angelina.
Angelina.
Yes.
Okay, Angelina.
Allotropy is the existence of an element in more than one form without change of state.
Okay, thank you. But you're defining allotropy. Allotropy. So, Shami, from allotropes, we also have what we call allotropy, and that is what Angelina is defining. You can repeat for her.
Allotropy is the existence of an element in more than one form without change of state.
Okay, thank you. So thank you so much for saving the situation. So let's look at the chemical properties. A reaction with oxygen. We are going to look at reaction of carbon with oxygen. So carbon burns in excess. Let's take note of this word excess. Carbon burns in excess oxygen to form carbon dioxide. Carbon burns in excess oxygen to form carbon dioxide. So this is what is formed. M is missing. To form carbon dioxide gas. So in this process, we generate a lot of heat. A lot of heat is formed. So you find that in some books they will come and add here the word heat to show that the heat was given out or it was generated. So this is the equation. We have our carbon here burning in oxygen, and we are saying excess oxygen, and then we form carbon dioxide gas, and that happens when we have excess oxygen. So again, we have when carbon burns in limited amount of oxygen. When we use the word limited, we mean less oxygen. What if we had less oxygen? Then there would form carbon monoxide. There carbon forms carbon monoxide. The other time we are forming, here we formed carbon dioxide, which is here, it is CO2. Then this time round, when we have limited, we form carbon monoxide. So this is what we form, carbon monoxide. Carbon monoxide, it is CO, just CO. But then we're saying carbon dioxide, for it is CO2. You need to get to know that the difference is that CO2, when we have CO2, that is carbon dioxide, and only happens when you have excess oxygen. And when we have less oxygen, you form carbon monoxide. So we are having this word here. The word mono means one. So we are forming one oxide, and we call it carbon monoxide. So this is the equation. So if they ask you the different equations or the different observations when carbon burns in oxygen under different conditions, one would be excess oxygen, we form carbon dioxide. Limited or less supply of oxygen, we form carbon monoxide. Then a reaction of carbon in a deep or bright glowing coke. So this is a common diagram. This is a common diagram, and we can demonstrate this like when you have a burning charcoal stove, when you have a burning charcoal. Yes, Kim. Kim. Kim, you can talk to us. Kim, I'm not able to hear you. I don't know whether there is someone who is hearing you. Anybody hearing what Kim is asking or is telling us? So Kim, it seems maybe your network is not all that clear. You can use the chat. I will be able to get your question. So once again, this is like a charcoal stove. We can use a charcoal stove as a good example. So whenever you have a charcoal stove, assuming that it is like this, most of the charcoal stoves, they have a hole here. So here we can have maybe that part which contains the charcoal, and at times you also find it has some holes here which are rectangular, rather triangular, and the ash normally collects at the bottom. Kim, I will not be able to go through everything that we have so far covered. You have to wait for the notes in the classroom, in our Google Classroom. I'm sorry that I can't repeat for you right now, but we are looking at carbon and its compounds. It's a continuation of what we looked at the other time in the first phase. So this is our stove, and here we are having the charcoal on top, and I said these are holes. They are always around the charcoal stove to allow in oxygen for burning. So you find that at the bottom, normally at the bottom of a charcoal stove, there is too much heat. You find it red. Then in the middle, it is kind of burning, but the burning is not all that much. Then on top, it is burning. So it means that at the bottom, since we have this hole, it takes in oxygen, a lot of it, and there is complete burning. But in the middle, there is not much oxygen because of being in the middle. The oxygen cannot penetrate to the middle very well. Then on top, we also have oxygen from the surrounding. So that's why we also have that reddish thing on the stove, charcoal stove. I say that carbon monoxide, it is formed, I'm responding the question from Rusty. Carbon monoxide is formed when we have less oxygen or limited amount of oxygen, and I was also trying to differentiate its chemical property, its chemical formula, which is CO, from that of carbon dioxide, which is CO2. So this is our charcoal stove, and we are seeing that this is air, like the way it passes through that hole of a sigiri. We call it a sigiri in Uganda, and I think in other languages it is a sigiri. So we normally have the ash at the bottom. The ash collects at the bottom after burning. So we have part A, where there is burning, serious burning because of that oxygen. Then we have part B, where there is incomplete burning. We also have on top where there is too much burning also. All those ones is because of the presence of oxygen. When we have too much oxygen, then we shall have complete burning. When it is less, then we shall have incomplete burning. We can demonstrate this using this diagram. So this is our charcoal burning. So there is where we have, let me change the color of my pen. For example, here, if you can see very well, you can see that like here we have where it is very red. I'm trying to write there with a red black ink. So here it is red, here it is also very red. So that is where we have that complete burning, and it is at the bottom. But again, we also have this part. For example, let me change the pen. there is this part like here. If you can see where I'm putting my red, or I can change and put let me put blue and see if it can be visible. So we have this part where there is incomplete burning, and also have on top, you can see that on top the ash is already forming. Like here, the ash is already forming, meaning that on top there is too much burning. So if you go back to this, we have A, that is at the bottom where we have complete burning. Then we have B where we have incomplete burning, and we also have on top where we have complete burning as well, because of having that oxygen. So in region A, that is this region, in region A we have plenty of air which is available, and carbon burns to form carbon dioxide. So this is what we call complete burning. Carbon burns completely to form carbon dioxide. Then in region B, ascending carbon dioxide is reduced by red hot coke. Then we form carbon monoxide. Ascending, that is going up. That is going up. In other words, if at A, after carbon burning with other air, it forms carbon dioxide. Okay? And remember, we are saying that we are using coke. So this coke that is burning, here in the middle here, we don't have the coke. We don't have the burning. So we still have coke. So the coke here is going to reduce the ascending. That is the carbon dioxide going up. Carbon dioxide going up. Then it is going to meet with the coke. Then to be reduced to carbon monoxide. That will take place at B. So that is what we mean here. Then at the surface, the hot carbon monoxide burns in air to form carbon dioxide. So the other carbon monoxide being formed, it is going to react with oxygen that is from air, which is in the surrounding. Then we form carbon dioxide. So that is why it is not good to have that charcoal stove in a closed environment or in a closed room. So that, because once you do that, it means that this carbon monoxide that was formed in the charcoal stove will not burn. It will remain carbon monoxide. And carbon monoxide, it is not good for our health. It will cause suffocation, and you suffocate, then eventually you will die. Galaxy A2, you first tell us your name. Galaxy, talk to us. Hello. I'm not able to hear you. You can use the chat. Let's use the chat. So like I was saying, that it is not good to have the burning charcoal stove in the house, because it will cause to suffocation. You will lack oxygen, and eventually you will die. Okay, and again, if the house is closed, it means that it has less oxygen, and even though there is burning, this carbon monoxide will keep on burning with that less oxygen present, and eventually all the oxygen will be used up, and you won't be having the oxygen too for breathing. The page, someone is asking for the page. I haven't posted the notes. I will post them after the lesson. So that's with carbon burning with oxygen. So normally this comes in an exam asking you how they can draw for you this diagram. This diagram can be drawn for you, and you'll be asked to talk about what happens at A, what happens at B, and what happens at the surface. Or maybe at time they can ask you, why is it not recommendable to have a burning charcoal stove in a closed house or a closed room or closed environment. So that is the end of our lesson today. That is the end of our lesson today. So maybe if we can, if time allows, we can check the videos. Let me see if we can check the other links. So we can check for the sugar chapel. It is the one which is a bit shorter, given that the time is almost up. So I can copy and then I come here and look for YouTube and paste it there. Are you able to see? Let me share it again. Share sound. So this is the
breathe. 3, 4, and
so let's watch this video for a formation of sugar charcoal. So what we have in this beaker, it is sugar, and this man is adding their concentrated sulfuric acid. So let's watch and see what will happen at the end. So what you're seeing here, if you see my pointer, this is the sugar charcoal being formed. So our sugar has lost the other white color when the water was removed after adding concentrated sulfuric acid. So this is what we call sugar charcoal. try to read what is being written here. Concentrated sulfuric acid is mixed with household sugar. When we talk of household sugar, that is the normal sugar we have at home, which is attacked by the acid and hydrating agent, the one that removes the water. The final products are carbon, water vapor, and sulfur dioxide. So that is those are the final products. Of course, with this is the sugar charcoal, and the sugar charcoal, it is in this case our carbon. The vapor, you are seeing it coming out, and sulfur dioxide, which is a colorless gas. I saw a hand. Okay, it seems I was trying it out. Okay. So you can see these fumes here. That is carbon dioxide, sulfur dioxide. Example. This is also another example. This is also sugar, and sulfuric acid is being added